Hi my dear students, this is the first lesson about the conic sections, and the first conic section that we are going to learn is parabola. It's going to be, and we are going to start with the basic elements of the parabola, and here are some definitions. I'm going to read them and I'm going to explain them. What are they? Firstly, we are going to start with the focus and directrix. Actually, you know what is parabola from quadratic equations. When you were in second grade, you learned this one, but in conic sections, the parabola definition a bit different. Let me read what it is. A parabola is a set of points in a plane that are equidistant from the fixed point and fixed line. Here, the fixed point is called the focus, and the fixed line it's called the directrix. The y-axis it is chosen as here it is directrix, and any point when you get on the parabola, you are going to check the distances. The distance to directrix, it should be always perpendicular distance, and this distance, that's called also the closest distance, because when you draw to this side or to this side, it's not going to be the closest one. The closest distance to the directrix is perpendicular one, and the distance from the point and the focus, always they are equal to each other. As you see, any point chosen on the figure, here the green one is the parabola. Any point chosen on the figure, they are equidistant to directrix or focus point. Here AF, AK is equal to AF, QL is equal to QF, or any point that I am choosing now. Here I want to choose at this point. Here I want to choose, and I'm going to draw one line to this one. I'm going to draw one line from this point to this one, or to this one directly. Here when I draw line, you're going to see that these distances, they are going to equal, or if it is parabola, the distances must be equal to each other. Okay. What is axis and vertex? The point on a parabola which is closest to directrix is called vertex. Here these points they are called the vertex point, which closest to directrix, and this is the D1 is the directrix, and the closest point, these points they are called the vertex. Also, left side of the vertex and right side of the vertex, they are equal to each other, so it's easy for us to understand which point is the vertex. Okay, the line is perpendicular to directrix, which passes through the focus. It's called the axis. So axis of the parabola, here this is the x-axis, is the axis of the parabola. Here this is the axis of the parabola. Opens to the right, it says down, opens to the left, opens upward, opens downward. So these are the axis. This one is the axis, which is the focus on the axis, the focus point. Here it is. This is the focus point. It's going to be. This is on the axis, and this point it is on the. This is the focus point. It is on the x-axis, and this point is the focus. It is on the x-axis, and this point is the focus, it is on the axis. It's going to be. Okay, let's continue with the other definitions. The length of the line segment between focus and directrix of a parabola is called parameter of a parabola, and it's notated by P. And as you see on the figure, Fk is equal to P, and this distance totally it is called the parameter, and the length is P. And FA and AK, they should be equal to each other, so that's P over 2. And if it is on the y-axis, this distance it should be x is equal to P over 2, and this distance it should be x is equal to minus P over 2. What is eccentricity? Eccentricity, firstly I need to tell that eccentricity of the parabola, always it is equal to 1. What is the eccentricity here? When you get one point on the parabola, the ratio between the directrix and the focus point is going to give you the eccentricity. And we know that for the parabola, it's always equal to each other. I mean, the distance between the point and the directrix, and the distance between the point and the focus point, they are equal to each other. So you are dividing the same numbers to each other. That's why the ratio, it should be equal to 1. So eccentricity always equal to 1, and this is general definition for the conic sections, and we are going to learn in other subjects also. Okay, what is directrix? Directrix, at the beginning we have talked about how to find the directrix formula. Actually, it is given here. If the here the important part, the corner point or the vertex point, it should be on the origin. If it is on the origin, always the focus point, if it is p over 2, then the directrix, it should be on the minus p over 2. That's the most important part. So from here, this distance, if this is equal to always p over 2, this distance, it should be also p over 2, and you are finding the directrix with respect to focus point, or you are finding the focus with respect to directrix. It should have equal distance to each other. Okay, let's solve some exercises. Exercises are very easy for us. Here, what is the focus of a parabola is 3, 0. The 3, 0, the x value is 3 and the y value is 0, which means this point is the 3, 0. So this is the focus point. If the focus point on this side, the most important part here I'm explaining now, the parabola, it should be like this, because our focus point always should get its value inside the, if I define this part is inside the parabola, it should get the its value inside the parabola. So if the focus point is here, which is 3 and 0, which is given here, find the equation of the directrix. The distance of the directrix and the parabola, it should be same. So this is the point that the directrix is passing through, and directrix, it should be perpendicular to the axis of the focus point. I mean, which is on the focus point, or focus is on the axis. Actually, that's the true one. So this should be perpendicular to axis, and it should be like this. And I'm drawing now that one. This is the directrix now, and you remember from the equation of the line, if it is perpendicular to x-axis, then the name of the line, x is equal to the point that is passing through the x-axis, which is minus 3 here, and that's going to be equal to minus 3. So the equation of the directrix, it's going to be equal to x is equal to, minus 3 line. Find the focus and eccentricity. Actually, this is a very easy question. I mean, the eccentricity part is always 1. In parabola, there's no need to do calculation. Okay, find the focus point. So we are going to find the focus point. The parabola whose vertex is at the origin. So the vertex is here, and the y is equal to, the directrix is y is equal to 5. So I need to find y is equal to 5. Here is the 1, 2, 3, and 4, and 5. It should be on the y-axis per se, and the point 5, it's here. So this is the point the directrix is passing through. And if I draw the directrix to this side, like this, maybe I need to get it a bit up here, like this it should be. That seems more better. Okay, this is the directrix line. If it is the directrix line, it means that our parabola, it should lay down, because it should be opposite to directrix. So our parabola, it should be like this, firstly. And if the point is here 5 unit, to the other side also it's going to be 5 unit, which is here 1, 2, 3, 4, 5, which is 1, 2, 3, 4, and 5. Sorry, I made a mistake here. This is going to be the 5 unit distance. Yes, this is 5 unit distance, but the coordinate of the point is 0 and minus 5. It should be, because it's downward on the x-axis. The x value is always 0, and since it is on the negative part of y-axis, it should be minus 5. Okay, so find the focus point, it says in the question, and this is the focus point, and you can easily find that one. This is the last question, and find the parameter of a parabola with focus f0 minus 4. And find the parameter, it says. We can find parameter, directrix, eccentricity, always 1. But here in this question, they are asking only the parameter. Parameter, if you remember, it was equal to p. And we know that here it is equal to, this is equal to p over 2. If p over 2 is equal to minus 4, then p, it's going to be minus 8. This is important also. But p is distance. Since p is distance, it cannot be negative. P must be equal to 8. If I show the figure on the graph, 0 and minus 4, it's going to be here. This is the focus point. And here 1, 2, minus 1, actually minus 1, minus 2, minus 3, minus 4. This is the focus point. And the parabola with focus vertex is at the origin. This is the origin, and the vertex, it should be like this. The parabola figure, it's going to be like this. With respect to that one, if the focus is here, this is the f, then the directrix, opposite side, same distance it should be. So minus 4 to the opposite side, it's going to be here, which is 4. So this is the line directrix is passing through. Then this is the directrix, and the total distance between these two, it's going to be equal to 8. And if you are talking about the distance, it should be equal to 8.